This is what epsilon r. How to find out the capacitance of this such system. So look at epsilon, look at the epsilon r, in what direction it is increasing. It is increasing along x-axis, no? And the separation between the plates is equal to the area of cross section of plates is E. We have to find out the capacitance of such a system between 1 and 2. So what we had a slab, the slab of uniform dielectric constant or uniform relative permittivity. What about here? The relative permittivity is going to vary from one end to another end, from one plate to another plate. So here, what is the best method? I'll go for it. I'll assume a. So shall I assume here? I'll assume a slab of width dx. Then I'll assume another slab. What will happen to the flow of charge? Will remain same. No? If I assume two identical slabs, then what is the flow of charge through them? Will be same. So therefore, all these elemental dielectric slabs, how they are, they shall I say they are in series. If you assume one more, if you assume one more here, if you assume one more slab here, then all these how these two elements will be in series. Now what charge passes through, the same charge will pass through it. So these two elements are said to be in series. So then what I do is like I'll take help of the capacitance. Like first we'll find out the capacitance of this small element DC. So what is it? DC is equal to epsilon r, epsilon naught. Area of cross section will be that of area of cross section of plate only by dx. What is epsilon r? Alpha plus beta x. Then all these elements are in series. So what is the effective capacitance? We do write like this, no? Same thing already in thermal conductivity you have come across. The similar condition I'm going to introduce here. Epsilon r, epsilon naught, A by dx. So this dx so what should be the value of x? Should be 0 to d. Substitute this alpha plus beta x. Integrating this, substituting limits, will get the effective capacitance. So this should be 1 by beta log of alpha plus beta x 0 to d. Can be asked in exam. It is there in EDO. So possibility of asking as it is also. Beta d minus log of alpha. So therefore this should be f naught a will come outside here. No? So the capacitance will be C is equal to beta epsilon naught a by log of 1 plus beta d by alpha. So this is the capacitance of this system.